Hello, everybody. Greetings, and thank you for coming uh, on my talk, on my quick session today. Um, well, first things first, some introductions I think are in order. My name is Dimitris Pappas, and I'm currently the Chief Technology Officer at I Know How, or for those of you that prefer acronyms, IKH. And well, deep inside, I always like to say that I'm a software engineer at heart, so we'll take it from there. Now, we have quite a few things to discuss and barely enough time to do so I'll try to start right away. Today's session is about the unsung heroes of software development. Well, the thing is that as software engineers, we always like to talk about the latest trends, the latest and greatest frameworks, whether it is Spring Boot or Quarkus or your Node.js or Angular or React, whatever is your cup of tea, we always tend to prefer the main stacks. And that is, that's normal up to a point, because at the end of the day, it is the scaffold upon which we build our business logic and our applications. But the thing is, how often do we take a step back and think about all the tools in our everyday lives, in our everyday lives as developers, the tools that actually make our lives easier, that might not be as sexy or as elaborate, or they may not warrant their own discussion on our private chats. But without them, we would be really in trouble. I mean, these are the tools that make our lives easier, or at least more tolerable as developers. And building an application is only half the battle. We have to, after the design, after the development, you have to actually test it. You actually have to deploy it. You have to manage it. You have to, maintain it. And there is a whole suite of tools that we use every day for that. So this session in this session, we'll discuss about a couple of them. We use them in our real use cases, in real projects on I Know How, and they did make a difference for us. So let's explore them. Okay. So in our use case, we had to use Kubernetes, and don't get me wrong, Kubernetes is great until you actually try to develop in it. Microservices are all the trend, and they have been the trend for the last 6-7 years or so. Now, whether every solution warrants microservices, that's another discussion altogether. But despite that, we do tend to use microservices a lot more. And the problem is that they come with their own set of problems. Okay, they have a very steep learning curve, and they put a huge toll on development teams, especially development teams that are of variable experience, of variable backgrounds. There are even senior software engineers that actually have trouble following the Kubernetes logic, because it requires a paradigm shift in the way we develop things, and that's not always easy. So there's that. There's also the lack of fast feedback during development. Think about it. When you're actually developing applications for Kubernetes, to be deployed in Kubernetes, especially microservices, actually developing on them and testing them live, and I don't mean unit tests, integration tests, nothing of the sort. I mean the kind of tests that you're doing when coding. It's quite hard to do, in fact, because if you think about it, the whole life cycle requires you to, if we're talking, for example, for a Java application, it requires you to build the jar, to have prepared the Docker file, and then build the image, and then push the image to the container registry, and then gather all your YAML files for the Kubernetes, build the manifest, apply the manifest, and try your code, only to discover that you missed your change, and you need to rinse and repeat the whole process again. Another problem is the inconsistent local environment. Now, granted, this is not a problem only for Kubernetes. There is always, this meme quality of it works on my PC, and Kubernetes is not exception to that. But it only, it makes it even harder for teams to follow up because there are wizards, there are software engineers that are experienced and try to work around all the problems and the overhead with custom scripts that do work, but they're not universal, okay? Each and everyone uses their own scripts on the APC and they end up having a nightmare to maintain. And, well, regarding the deployment, well, as I mentioned, there are so many different components of Kubernetes. I mean, there are services, there are deployments, there are replica sets, there are ingress routes. There are so many things that you have to configure in YAML files, which starts to feel more like, YAML engineering and less like actual development. So, what did we do? And now I know how we used, well, how many of you have you heard of Skaffold? Okay. Well, I hope that after today, more of you will have heard of it. Skaffold. Skaffold is a tool from Google. Okay. It essentially is a tool for abstracting this whole complexity in developing and testing and deploying on Kubernetes clusters. As I mentioned, the whole purpose of it is to have a single way to work when working with microservices, well, generally with applications, but even more so with applications based on microservices, and working on Kubernetes. It makes it easier, and it makes it, maintainable because everyone in the team has the same way to develop. It supports hot reload and sync code, which is godsend, especially for frameworks that do not natively support it, or kind of support it, but in a more, hacky way that doesn't always work. Spring Boot comes to mind. And it doesn't need to rebuild the whole container to do that. It actually watches your code for all the necessary changes, whether it's, classes compiling or differences in the actual output on your target files, and just injects those target files into your running containers. So you don't have to actually build the whole image from the start and deploy it. It also has a common configuration and setup across teams. I mean, everything happens within a Skaffold YAML file, which holds all the configuration needed for Skaffold, and we'll see an example of that later. And this is also, something that you can hold in Git. It's you can version it, and everyone has it. Everyone has the same, actually, the same file. And finally, it makes it easier for you to actually deploy your application after you've done, and hopefully everything works as intended. It makes it far easier for you to deploy, either as a part of CI/CD pipeline, or even manually in some cases. Hopefully those cases are not very often, but it happens. Now, if you realize, I mentioned somewhere that it builds the image. Part of the whole process is it actually builds the image for you. Now, we used another tool for the building image process that doesn't require Docker, and this is Jib. Okay, that's another tool that we used. Fun fact, Jib, even though someone would say that it stands for Java image building, this is not actually accepted by anyone officially. Jib is just a type of sail, and it follows the naming scheme of all the Kubernetes related, all the nautical terms, Kubernetes, Helm charts, or Istio, and whatsoever. Jib is an application which also comes in the form of a Maven plugin or your Gradle plugin, or also a CLI, a command line application, that is able to containerize Java apps, specifically Java apps, without needing a Docker file. And without needing Docker at all as an executable. This is quite important, and not requiring Docker, not having a dependency on Docker is a good thing, but an even better thing is that when building the actual image, Jib doesn't rebuild the whole image from scratch. Okay, it caches pretty much everything needed. I mean, it supports pre-built images like OpenJDK or several versions of that. But once it caches the related image, it only injects the part that are related to your application. Now, Docker sometimes does the same thing itself, but more often than not ends up building the whole image from scratch. Now, the fact that it works with Maven or Gradle, it means that it allows you to bind the building process and the image building process to your application building, to the life cycle of your application. It allows you, for example, to have, when you build the actual application, to also have the same image built to be sent to your private container registry, already available to be deployed or to be tested. And yeah, as I mentioned, it supports dependency analysis to rebuild only what's changed. Okay. Now, the reason we also chose Jib is that it has a great synergy with Skaffold. Okay, it's a match made in heaven because you can use Skaffold for the whole development cycle, and once you're ready to test it or once you're ready to deploy it, you can use Jib to build the image and push the image to the registry and have it deployed by Skaffold. Sorry. So, time for a demo as to demonstrate how easy it is. I mean, it always seems easy at demos, but you will see what I mean soon. So, let me check here. All right. Hopefully you can see better now. Yeah. So here we have a couple of small sample apps, nothing too fancy, 2 Spring Boot apps that are intended to be deployed on a Kubernetes cluster, named Devoxx 1 and Devoxx 2. Very simple, very same. The only thing they have is essentially a controller, a single controller with 2 endpoints, one hello and one greet. Hello essentially prints a message. Greet uses a faint client to actually call the other microservice. Devoxx 1 calls Devoxx 2 and vice versa. 2 essentially prints each other's messages. That's it. Nothing too fancy, just to showcase what we're going to do. Here you can see the related Kubernetes folder where we have separated our YAML files for the ingress, for the service, and depending on the profile we're going to use, the Maven profile we're going to use, the related YAML for the deployment. And at the root of each and every one of them, you can see a Skaffold YAML, which looks like this. Essentially what you have is, well, a specific configuration dedicated to Skaffold. The important things that you have to check is the fact that we are naming our image. You can see that here we can also have profiles. This is the default profile, the dev profile, that we don't need any fancy names. When you push the image from the dev profile, it essentially goes to your local registry. If you have installed Docker, or if you have a Minikube, a local Minikube development environment, it goes to your local image registry. Or you can define, as we can see here in this profile, a private Docker registry, a container registry, not necessarily Docker. And we also use Jib as our building tool. So essentially, you don't really need Docker for the building nor for the testing part. Okay? You can also have one scaffold per microservice, or if you take the monorepo approach, you can also gather, your central Skaffold YAML file to have pretty much all your microservices deployed and run at the same time when you want to test. Okay, so if I wanted to test this, I would essentially have to, for each and every one of them, I would have to build the jar file, push the image that I've built with Docker and Dockerfile, push in the container registry, apply on the Kubernetes cluster, and cross fingers. I'm not going to do any of that. Instead, I'm going to do a Skaffold dev and well, for the sake of brevity, I'm going to skip the test because who needs them? And yeah, right now, Skaffold does the whole process that I described previously automatically. It checks for the already existing potential images. It watches for changes and essentially starts in my local cluster, in my local Minikube cluster. It starts our microservices, and that is done. And I can open a Minikube dashboard here. Okay, you can see that we have, all the pods, all the deployments, all the electrical sets right here, already deployed for us. And well, that's a Minikube-related thing. I can expose these services because it's a local environment that I don't have ingress routes for that. We can see that we can use Devoxx 1 to say hello. Hopefully say hello. Yeah. Let me check. All right. Okay, yeah, typo. All right, so we have this one essentially just prints a hello world and the name of the pod that is running, and we can check that here because, one of the pods is named like that. And we can go to the other service for the Devoxx 2 and also say hello. We can also hey greet, and we can see that the message is from the Devoxx 1. That is the functionality. Okay, let's just say now that I want to go to Devoxx 2 and just change the message that is printed on the greeting. Okay, running from Devoxx 1, 2025, for example. Hit save, and you can see that Skaffold already takes my changes, it recompiles the changes, and it will inject those exact classes into my currently running container without me having to do anything at all other than wait just for a while to everything to stabilize. And you can see that, yeah, everything has started up. And if I go to Greet 2, here we are. The change is here. I haven't done anything other than doing my job, developing, reloading, hot reload at works. You can see that as soon as I hit Control-C and stop the Skaffold dev, pretty much my local Kubernetes Minikube is done. It's cleared. Everything from the pods, from the services, from the deployments, the replica sets, whatever I have deployed as a part of the development cycle is cleared. This is essentially the development cycle, and we can also use Skaffold to deploy to another Kubernetes cluster. Let's say that I want, for example, to use the micro Kubernetes profile, which is a different profile right here for different configuration. And as we can see in our Skaffold file, this profile micro Kubernetes intends to be applied to an external Kubernetes cluster with an external configuration. So what we have to do is, again, use another command, scaffold run, assign the profile that we want, and we will also skip tests because, once again, who needs them? And right now, Skaffold checks my private container registry for whether the image exists or not. If it founds, it skips the pushing process. But if it doesn't, it will build. Yeah, the build is successful. And as you can see, it will build the second Devoxx microservice. Keep in mind that I haven't used Docker at all. I mean, I know that Docker is running because I have Minikube cluster running, but I can very easily stop it, and you will see that it still works. So. Now, this will take some time because essentially it pushes the whole image to my private container registry, and I don't know how fast the internet is. But as soon as it finishes, we will be able to check our staging cluster, and we will see that the changes will be deployed there as well. Now, why this is important? Because, as you can see, Skaffold allows us to, no matter how well or not well we know the whole Kubernetes lifecycle and the whole quirks that go with it, we are able to focus on code without expecting each and every member of our team to know the specifics of either Kubernetes development, either microservices development. We instead focus on code and leave the deployment process to a tool that is dedicated for this job, and it's far better than any script that we will manually build. And as I also mentioned, it can be a part of a CI/CD pipeline by simply installing a Skaffold as in whatever VM or whatever machine you use to build your applications. And yeah, this will take a while, but you get the idea. All right. So that's about it for Skaffold and Jib. But we do have one more thing, or one more tool to check. Now, yeah. I can't count the times that a client might have asked for a simple, export Excel or an export CSV of simple tabular data, nothing too fancy, no BI tool, no business intelligence, no statistics. So yeah, since this is the requirement, you end up just hard coding and export Excel. I mean, there are so many libraries that do that you don't need to process this any further. But the thing is that people become addicted and greedy with data. So clients, as soon as they get their hands on the first version of your application, you can be pretty confident that they will end up needing reports and statistics that they never had discussed before and never had provisioned before. And in fact, that is what happened in one of our use cases. And of course, you can describe or prescribe a dedicated business intelligence tool. But what we ended up doing instead was to use Metabase. Now, how many of you have heard of Metabase? Okay, a little bit better than before, but yeah. So Metabase is an open source tool. I mean, it is, for all intents and purposes, it is still a reporting tool. But it's a reporting tool that abstracts all the complexity of tools like Cognos or, I don't know, your Jasper reports maybe, or Power BI even. It is focused mostly around the usage from the user's perspective, okay? You don't really need to be a developer or engineer to use it, and to use it very proficiently. Of course, the more advanced knowledge you have, the better the dashboards and queries you can build. But you can really use it without pretty much having any background on developing whatsoever. And that makes it very, very good for use cases where you have the client needing to adjust certain aspects of reports without you interfering all the time and without wasting precious resources and precious development time. It also supports multiple types of visualizations of charts, heat maps, whatsoever. It has a fully documented RESTful API, and it's quite easy to integrate within your application, so you don't have to use any, iframe of sorts, which should finally go away. You can embed it in your applications, and it will be as if essentially you have it built in. And because a picture is worth 1,000 words, we're going to see a very small demo once more. You can see here, yeah, no, that's not the correct port. All right. So what I've done here, this is the main screen. What I've done here is I have prepared a very simple table of, tabular data. These are data from our local Git. Some of you may recognize it even. There are commits from an internal microservice project that we had. There's 196 commit messages here. And you can see that I can do, with Metabase, what you build actually is you build models. And these models, you can use them directly from the UI. So if I want to filter by this column, there are multiple operations that I can do. If I want to filter by, let's say, only from those that Vasilakis has done, okay, here we are. And imagine now, this might seem very simple to you because you know how it works, but imagine you are the end user and how easy it is to essentially, other than doing filters, you can also summarize columns. For example, I can summarize by how many commits each user did, and I can also change the visualization of this. Instead of having tabular data, I can select a pie chart. Okay. I mean, how many steps did that take? 3, 4? And I have a pie chart, which I can also customize. I mean, if I don't like the labels, I can change them. If I don't like how many or how small percentages are being shown, I can show only those that are more than 40%, okay? And group the rest of them. There's a whole suite of tools here on Metabase. And the fact that you can also assign RBAC, I mean, role-based authentication, and you can assign dashboards. You can actually prepare dashboards, like, for example, this one, that only have the information that you need. You can display them on your local site. You can assign buttons or filters that can be used. And as the cherry on top, each and every one of them allows you to export to Excel, JSON format, CSV, or even PNG if we're talking about charts. So, obviously, this is by no means intended to be an exhaustive list. There are literally thousands of tools available every day, literally thousands of tools. And we use tens, if not hundreds of them, depending on the stack. A good wrap-up would be, this session is nothing more than, food for thought. We should, every once in a while, just take a step back, relax, and think about all the different tools that make our software development lives easier. And, just the fact that there are small tools doesn't mean that they don't have big impact. They save time and effort. And at the end of the day, I think we should just appreciate them a little bit more. That's it. Thank you very much. Now, I really hoped we had more time for this, but it is what it is. If any of you had any questions or have any, you want to just chit-chat, please come by our booth on the first floor, and maybe I'll see you there. Bye-bye.